Welcome back to your Algebra 1 Semester 1 final review. We're looking at problem 31 today, but as long as your problem looks just like this, don't worry about the number. It changes from year to year. They gave us the equation of 4 lines, which means if we graphed these, and notice each one has an x and a y, they're all going to make some sort of diagonally sloped lines. Okay. Now they're asking us which equations form a system with no solution. So we really have 3 types of solutions that can happen when you graph lines. And I'll do one in blue, one in green. You could have a line that goes in an upwards direction, a line that goes maybe in a downwards, maybe in the same upwards direction. But regardless, these 2 lines crossed in one spot. This would be an example of 2 equations that form a system with one solution. You could also, of course, have 2 lines that are exactly the same, right? It's possible that you're following 2 people that maybe have the same salary, and so their equation of how much money they're making each year is just one right on top of the other. And so if they're right on top, that was right next to it, if they're right on top of each other, then they would intersect, or they would cross everywhere. And so these ones, since they cross in an infinite number of spots, we would say have an infinite number of solutions. And last but not least, and I imagine you already know this, you could have 2 lines where one is sloped in one direction and the other one is sloped in the exact same direction, and they never cross. And these 2 are ones that form a system of no solution. So we are looking for 2 lines that form no solution today, and if they form no solution, they don't cross. And the reason they don't cross is because the 2 lines are going up or down at the same rate or steepness or slope. In fact, we'd say these 2 lines are parallel because they have the same slope. So our 2 equations that form a system with no solution have to have the same slope. Well, we didn't actually graph the lines in this table, but let's take a look at these and see if we can figure out which ones have the same slope. Now, remember that in order to see the slope of the line, you really want y to be by itself. If y isn't alone, you can't always assume the number in front of x is the slope. So for example, on this first equation up here, there's an invisible 1 in front of x, and hopefully you guys have been trained that the number multiplying by x is the slope. 1 is probably not the slope here because this y over here is not by itself. So let's skip line 1 and move on to the rest. Line 2 has a slope of -2, y is alone. Line 3 has a slope of 1/3, and line 4 has a slope of -1/2. So lines 2, 3, and 4 are all not parallel. They would all cross somewhere because none of them have the same slope. That means that our answer has to have line 1 and one of the other 3. And can we eliminate any solutions here? Well, it can't be B. 2 and 3 don't have the same slope. It can't be C. 2 and 4 don't have the same slope. So it either has to be lines 1 and 2 or 1 and 3. So 1 and 2 would have to have a slope of -1/2. 1 and 3 would have to have a slope of 1/3. Well, I see a 3 in line 1. I bet it's going to match this 1/3 down here. However, let's see how we can actually find it. I'm going to start with the equation 1x minus 3y equals 9, and we're going to isolate y. And just because of personal preference, I always like to make the y positive first. So this minus 3y, my very first step is I'm going to add 3y to both sides. Now you could have subtracted 1x from both sides, that's fine too. But again, this is going to put our y positive. And notice that I'm just writing the 3y next to the positive 9 on the right side. Doesn't matter the order, you could have done 9 plus 3y as well. And now we're going to take care of the last 2 steps. To isolate y, we're just going to look at the side with y. There are 2 numbers attached. 3 is multiplying, 9 is adding. We should know we undo addition and subtraction first. So I'm going to subtract 9 from both sides. And then I'm probably going to run out of room here. So we have 1x, and we're subtracting 9, not like terms, so they stay right next to each other, equals 3y. There's still a 3 that's multiplying by y, and I'm going to switch things around before I go much further. I'm going to put the 3y first, times y, equals 1 times x minus 9. Just wanted to put the y on the left side instead of the right. I think we're more used to that. And now we do our last step, where I divide by 3. Now, on the left side, there's nothing too bad. 3 divided by 3 is 1. It makes 1y, but we don't have to write the 1, so it just stays y. But on the right side, we need to remember that multiplication, we see that more commonly, and division both have to be distributed to everything on one side. So we might want to think of this in parentheses to help you. And I'm going to distribute the division to every term on the right side. And it's going to look like this. I have a 1 that's going to get distributed by a 3. I should probably keep my same colors here. I have a 1, and that needs to be divided by 3. And then I have this minus 9, which also needs to be divided by 3. I'm distributing this division to each term. So now let's clean it up. 1 doesn't divide nicely by 3. If you do 1 divided by 3 on your calculator, you'll get 0.33333333. That's not very helpful. That's a decimal, and you'll notice all the slopes over here are fractions. Let's just keep it as the fraction 1 divided by 3. Minus, and then we have 9 divided by 3. That does go in nicely. That's 3. So here is my equation for line 1. And by analyzing it, we can definitely see that the slope is 1/3, which I think was a little bit harder to see at the initial step. So the slope is 1/3. Which other line has a slope of 1/3? Oh, that's line 3. These two lines are parallel because they have the same slope, and this is actually a little important, they have different y-intercepts. That means that they're going to start in different places on the y-axis and not cross each other. If they'd have the same y-intercept and the same slope, then they would have been the exact same line, and the same line would have had infinitely many solutions. So keep an eye out for that. Line 1 and line 3 are the ones that make no solution because they're parallel and never cross. The answer then has got to be D.